I hope you can see my screen right now properly. So as for my, I can say I solved these two problems actually in your class. So in the last, before the vacation, this one problem for actually from a flywheel rotation case. One question I select from actually a ladder which is placed against a wall, and one more question I selected actually a car wheel is rotating about this case. Actually these are the three questions as far I know I saw before the vacation, right? Fine. So if you saw, excuse me, I'm going to solve two more problem actually today from these topics. Then I will start the new topics. Actually the three, not two actually. So let's start. So let's say a particle position is given by that equation, which is right, r equal 4 t square I hat minus 2t plus 6t square j hat. This is the position of that particle is given.
Sir, may I say one thing?
Sorry?
স্যার আসলে আমার একটা কথা ছিল।
Sure, go ahead.
সেটা হচ্ছে যে আপনি যে আগের কিছু পেজ দেখালেন না যে ২ টা প্রবলেম সলভ করেছেন, ওটা একটু দেখতে পারি, একটু স্ক্রল করা যাবে?
This one?
স্যার ইয়েস দিস ওয়ান, বাট প্রবাবলি এই কোয়েশ্চেনটা স্যার আর ইউ শিওর যে এটা আমাদের ক্লাস স্যার?
I think so actually.
বিকজ আমি আসলে এরকম কোনো ম্যাথ আসলে আমার খাতায় দেখতে পাচ্ছি না, অ্যান্ড অ্যাজ ফার অ্যাজ আই রিমেম্বার আমি ক্লাসের কোনো পার্ট মিস দেইনি।
Uh, it could be. I could be wrong actually. Definitely.
আসলে আমার কারণ এই যে হ্যাঁ, এই ম্যাথটা তো খাতার মধ্যে নাই।
This one?
ইয়েস দিস ওয়ান অলসো পরেরটাও, কারণ আমরা যেটা করেছিলাম সেখানে ম্যাথ প্রবলেম তো স্যার দেখতে পাচ্ছি না, এটা তো থিওরি।
Uh, that's mean
Sir, as far as I remember, sir, you only showed the theory, no math.
in your section.
Yes, sir.
So up to this, that's when I talk about conservation of that angular momentum. This
Yes,
one
sir.
I done in your class.
এটা এটা হয়েছে, হ্যাঁ হ্যাঁ এটা হয়েছে।
All right, that's
Yes,
fine.
sir. Yes.
Okay, fine. So it's not a big deal. I do that program actually. Okay, it's not a big deal. I do that. Yeah, probably I could be because what I did, because I am not, probably I didn't make any separate sheet for your section. I'm using the same sheet for different section actually, so probably it could be missed. It's not a big deal. All right. So thank you very much. I'll do also three problem again that one. That's not a big deal. All right. Let's concentrate first on that one. So a particle position is given according to this equation. We know that one, right? We know we express that position of a particle using that part. Here is two-dimensional case actually. I hat and the z hat. It's a two-dimensional case actually in the xy plane. Now the first question they ask you, calculate the torque on the particle calculate the torque on the particle relative to origin, because we know that when I'm going to calculate the torque, we need to choose a point or the reference point actually. So that's why they are asking to calculate that torque on the particle related to the origin. Second one, what is the angle, what is the angle between the torque and angular momentum. So given that the mass of this particle actually is 3 kg, so that's when we have to find out the torque, which is the tau, and the angle between the torque and the angular momentum. All right, fine. Excuse me. So to find out the torque, basically we are going to use the torque we can find out using that formula actually. R cross F, right? We know that formula. We can find out that R because I know the position of that any moment. I can find out the R from origin at the location of that particle when I'm counting down the time. But the problem is there is no information about the force over here. They give the mass only, the mass of the object actually, the 3 kg. There is nothing about that acceleration. We can find out if I know that. But without doing that, I can do in another way actually to find out the torque, because there is a relation between the torque actually, that del L divided by del T, right? We know this one, which is actually that rate of change of angular momentum actually give you that torque, which is similar to the linear momentum actually. In the case you write down that net external force actually dP over dt. If you want to change that linear momentum of a system, you have to apply a force, external force on the system. Same thing, if you want to change the angular momentum of a system, you have to apply the torque on the system. So using that formula, we'll be able to find out that torque. Now the question then, how am I going to find out this angular momentum? L should be R cross P, because P I can find out, which would be easier for me actually. The P is actually, we know that, which is m into v, right? Mass into velocity. If they give me the mass, I'll be able to find out the velocity because I know the position. If I take the first time derivative, I'll find out that velocity, because we define that the velocity actually dr over dt, right? I know they give me the position actually, position over here, which is actually this one. All right, so that's actually the plan to solve this one. Fine, let's find out. Initially R is given actually 4t square I hat minus 2t plus 6t square j hat. This is my R. Then if I want to find out the velocity, so velocity actually dr over dt, then I have to take the derivative of this function. If you take the derivative, you will find out the 8t I hat minus 2 plus 12t j hat, I just simply take the derivative of that position function, this one, it will give me that velocity. Alright, so if I find out that velocity, then I'll be able to find out actually that angular momentum, which is L. L should be r cross p, and I can also write down p actually m into v, because I know the mass. Right now I find out that one, and I can also write down this one, m should be r cross v also, right? Because you see m is a scalar number, so that's why I can factor out that part. It's a, by the properties of the vector multiplication, you can write down this one. Fine. Now that's mean I am going to write down this part actually over here. L should be m into so m into, I'm writing in terms of, it's a cross product I j hat and the k hat, and this is the r. R should be actually that 4t square minus 2t plus 6t square and 0, because it's a two-dimensional case. Actually r is this one, our function is this one, which is 4t square I hat minus 2t plus 6t square j hat. I just plug in those value, and by the same way I also plug in the value of the v actually, which is this one. So if I plug in the value of v over here, it should be that 8t minus 2 plus 12t into 0. This is actually that part. So now if you take the cross product of this part, you will find out actually I and j component will be basically the 0. You will find out only for the k component over here, right? Because if you take the cross product, this 0, this part cross this part is going to be the 0. Same thing when you take the j component, product of 0 into 4t and product of 80 into 0, that will give you the 0. So that's why I'll write down directly this part over here. I can write it should be m into I cross 0, I cross 0 plus m into j cross 0 plus, I'm writing this one, plus m into k into, I'm writing this part, it should be minus 4t square. That's when I'm taking that product up with this one and that one, right? So 4t, that should be 2 plus 12t plus, it should be plus because there's the minus sign, and there is also the minus sign from this actually the formula. So then I'm supposed to write, or I can write down it over here. Plus it should be 80 into 2t plus 6t square. Now we can solve this, and if you solve, you find out L should be, if you solve, you will find out m cross minus 8t square minus 48 t cube. I'm just multiply with this part, plus 16 t square plus 48 t cube. Now this 48 t cube plus 40 t will cancel out. Then we will find out simply it should be L should be m into, it should be 8 t square k head, and I know that m actually the 3. Then you will find out this would be 24 t square k head. This is my angular momentum. Now I'm going to find out the torque. Actually, to find out the torque, what I'm going to do, I'm just take the derivative of that function, because the torque we are defining, which is actually that dl over dt, which should be simply, if you take that, it should be the 48 t into k head, right? This is the torque. This is the answer of the first question actually. If they ask you any particular time, you'll be able to find out that. Just plug in the value of the t, 1 second, 2 seconds, and 3 seconds, you'll be find out what should be the torque in that case of that part. Fine, so this is the first question. Now the second question, what is the angle between that torque and angular momentum? Can anyone tell me what should be that one? Because torque we find out, which is 48 t k head, and the angular momentum we find out L is actually that 24 t square k head. So what should be the angle between these two vectors right now? It should be the 0 degree, because they are in the same direction. Torque is towards the k head and angular momentum is also towards the k head, then angle should be the 0 degree. So this is the answer of this question. Alright.
Sir, I have a question.
Sure, go ahead.
Sir, for the first question, why are we dragging that angular momentum? I mean, if we find the first derivative, we find v, and after the second derivative, we can find acceleration.
Yeah.
So m into a, I mean m into a vector is equals to f vector, and r cross f is equals to tau.
Yes.
So can't we determine?
Yeah, you can do that. Definitely, I say that. I did that because in the second question, actually, they asked me to find out the angle between these two vectors. That's why I find out the angular momentum. Otherwise, I have to do the same calculation again to find out the second one. You can do in that way also.
Okay. Yes, sir. Thank you.
Alright, let's do another case actually. Let's say I have two object or two mass actually. This is actually that 6.5 kg is moving towards that direction, which is speed 2.2 meter per second. Another object is over here, which is actually 3.1 kg and is moving towards that direction with the speed which is 3.61 meter per second. Now I choose a point actually over here which is, I'm considering this is my origin, and from that origin the distance of that object is, let's say this is actually that 2.8 meter, and distance of that object which is actually 1.5 meter. Now they asked me calculate that angular momentum of these two objects about this origin. Let's say this is actually the point O. So I have to calculate that angular momentum of this system about the point actually that O. Fine. So I know that there is a formula we can calculate that angular momentum using that one. L should be R cross P, right? This is the formula actually for the angular momentum. You know that one. Fine. So we will use this formula over here simply to find out that angular momentum. So this is the formula we'll use over here to find out that angular momentum. Alright, so to find out, since I have the two object over here, let's say this is actually that object M1 I choose, and let's say this is actually that object M2. Similarly, you can say this is actually that R1 and this will be that R2. Then I can find out L1, it should be R1 cross P1, right? Or simply I can write down this one actually R1 P1. I'm writing in terms of magnitude over here basically. So it should be basically that side 90 degree. Am I right? Simply because this is the angle, this is your R, and this is actually your momentum. This would be the momentum direction P. This is actually angle. Same thing would be over here. This will be also the angle. This is actually your momentum direction for P2, and this is actually the R2. You'll find out same way. So L1 should be R1 P1, or simply I can write R1 M1 V1. That's all information is given actually, right? It's basically this is a plug and play formula over here for problem. Fine. So if you plug in this part, actually you'll find out that this one should be L1 should be R1 is actually 2.8, M1 actually 3.1, and this is actually 3.6 meter per second, which is that what I'm talking about this part. Alright, so then I can find out this L1 should be 31.25 kg meter square per second. This is actually that L1. By the same way, you can find out that L2, it should be R2 cross P2, or simply I can write in the second line, it should be L should be R2 P2 sine 90 degree, or simply it should be L2, I'm sorry, it's L2 would be R2 P2, or simply you can write an R2 M2 V2, which will give you L2 should be 1.5 into 6.5 into 2.2, or simply this one will give you actually 21.20. L2 should be 21.45 kg meter square per second, right? Now I have to find out this direction of this one, because I know the resultant angular momentum will be simply total L should be L1 plus L2 it's a vector. Now I have to find out the direction of this one. Come on. Direction of this part actually. Look at this. If this angular momentum for M1 actually would be towards that direction, which is counterclockwise, we'll consider this a positive, and M2 actually it will move, angular momentum would be towards that direction. It's a clockwise direction, right? So that's why we'll say that L1 will be positive and L2 will be negative. As a result, I'll find out that this angular momentum L should be L1 actually 31.25 minus 21.45, or simply I can write down this angular momentum of this one should be plus 9.8 kg meter square per second. So this would be basically that angular momentum of this system, total angular momentum of this system. Alright, so is there any question over here?
I didn't understand the minus part.
Sir, I didn't understand. Why did you minus 21.45?
Alright, so I say, look at this. If you consider the angular momentum for this object, which is P1 or M1, its angular momentum, or it is rotating about that counterclockwise direction, right? About this point, your origin. Do you understand that part?
Yes, sir.
But
Yes,
for M2,
sir.
it will move towards the clockwise direction. The rotation will be clockwise direction for M2. So that's why I say that if I say counterclockwise is positive, then the clockwise will be negative. We are trying to follow that convention
Okay,
over here.
sir. I understood.
Alright, so is there any more question? Fine, if you don't have, let's move forward to the other question. Alright, so let's say I have a, I don't know whether I can start a new gravitational cord. This is a wheel of cord, and I'm trying to go, I don't know whether it will be exact or not. Let's think about this is actually wheel of the car. So if you closely observe, this is actually the ring. It's not totally the ring actually, because there are some. This is actually the center of mass. This we will find out. This is one portion. This is actually the solid surface of this. This is actually the center of mass. What I did, I apply a 10 Newton force onto that wheel about that direction, which is the 10 Newton. Due to that force, that this wheel move towards the forward direction with the acceleration which is given, acceleration of the center of mass actually, which is 0.6 meter per second square. It is moving towards that direction with the acceleration a. The mass of this wheel is given, which is actually the 10 kg, and the radius of this wheel is actually 0.3 meter. Now they ask you two questions over here. The first question actually, what is that frictional force acting on that system? This is the first question. Second one, what is the rotational inertia of the wheel? That means I. These are the two questions actually they ask over here. Alright, so I can find out this rotational inertia of this wheel if it is totally a disc or totally is a ring, using those prescribed formula, right? Because we know that for the ring, which is only that surface, and it has also a vacant surface, or it's not continuous surface actually, right? You know that there is a hole inside the ring actually, it's not continuous surface actually. So, and also for the disc, you have that there is no hole, or it is basically the continuous surface, there is no hole into that disc. But the ring is not or this wheel is not completely ring or completely the disc. So that's why I cannot use those prescribed formula, or I'll provide into that exam. Actually, the moment of inertia of a ring actually through the center of mass actually mr square, and of a disc actually half of mr square. We cannot use that formula for this one because it is not completely disc or completely ring over here. Fine. Now to find out that frictional force over here, I need to draw the free body diagram of this system. Can you tell me how many force is acting on this on this wheel, not the fly wheel? Can anyone tell me how many force will be acting on that part? Say it. Hurry up, guys. Only the how many force? Can anyone tell me how many force will be acting on this wheel? Hello, can you hear me, guys?
Sir, 2 force.
2 force. All right. What are they?
Sir, 3 forces.
3 forces.
3.
Hmm.
Normal force.
Yes.
Gravitational
Normal
force.
reaction and
Normal reaction.
frictional force.
Frictional force.
Sir,
Good.
4 forces.
4 forces.
Yeah, frictional force.
Friction. 4 forces. Yeah, it was start from the 2. Right now it's come to the 4. Is there any one force? You started from 2 and it's come to the point right now number 4. Come on, guys. Still, if you have a problem with that, then it will be very difficult. Yeah, it should be the 4 forces over here, including this applied force. Actually, this 10 Newton. You will find out the 4 forces. One is actually your substitute a different color. What my? It's not working properly. So this would be your gravitational force, right? Which is actually the mg. I'm supposed to write. Come on. This is mg. This would be normal reaction force, and this would be frictional force. And this is also your applied force. These are the 4 forces will be acting over here. Alright, so to find out this frictional force, it will be very easy because I'll choose, this is my positive x direction and this is my positive y direction. I'll simply write down this net force on that system. I'll simply use the Newton's second law over here to apply, because the system is traveling towards my positive x direction according to this reference frame. The system is traveling towards the positive x direction with the acceleration f, which is given actually, which is 0.6. Then I'll simply write down f would be basically that ma. Then what are the force? And the x direction, I have the 2 force. One actually the 10 Newton, another actually that f. So 10 Newton actually the applied force. I'll write down 10 minus f actually that ma. I know the m is given, which is 10, and I also know that acceleration, which is given actually the 0.6. Then I'll simply find out f from there. So f would be basically that 4 Newton, because 0.6 into 10 it will be 6. 6 minus 10 minus 6 is going to be that basically the 4. This will be the friction force. Right. This is very straightforward. This is the part actually from your before the main we talk about for the Newton's law. Alright, so this is the answer of the first question. Now the second question, to find out the torque actually, to find out moment of inertia, I will use, there is a relation between the torque actually that I alpha, right? We talk about this one, which is simply that analogous F equal to ma. I say that m is analogous to that I, which is the moment of inertia, and a is analogous to the a, which is that linear acceleration and the angular acceleration. There is also the relation between the linear acceleration and the angular acceleration. You can find out because that a would be basically that alpha into r, or R alpha, you can find out. So, or if you forget about, you can write down those equation actually, that V actually that omega R, you know that formula, right? V actually omega R, from this formula you can also find out that one. If you take that derivative of the V, you will find out that A, if you take the derivative of omega, you will find out the alpha R is constant over there. So that's why this is also the relation between that linear acceleration to the angular acceleration I said you. Fine. So I will use this formula over here to find out that this I, moment of inertia of this flywheel. I can find out the torque, I can find out the alpha, because they give me actually that A, also that R. Then I will be able to find out the alpha from here. Alright, so then I'm going to find out that moment of inertia of this wheel about this actually basically the center of mass. This is my wheel, drawing it forward. So it is rotating about this center of mass. This is center of mass. I'm going to find out this moment of inertia of this wheel about this point, right? So then I have to also find out the torque of this wheel about this point. So I'll calculate that torque over here, because I have these 4 forces over here. If I draw that forces, over here, what's wrong? So this is one force, which is actually that your applied force 10 Newton. We should use the different color. So this is actually your 10 Newton. This is actually your mg. This is actually your frictional force. And this is also the normal force acting over here. Right. So I will calculate this torque about these 4 forces about this center of mass. So I'm going to find out that torque. I know that we are going to calculate the torque using that formula, which is actually R cross F, right? Let's calculate the torque about the point center of mass. So let's say this is the point actually that O I consider. So I am going to calculate the torque about the point O. What should I write? I should write actually, if I write down the torque actually using that formula, I'm writing this part. Look at this. I'll write down, this would be for the mg. I'm supposed to write mg into 0 plus n into 0 plus n into 0. Can I write this one? Are you understanding this part? What I'm writing? Plus n in plus 10 into 0 minus F into R. Can you write this one? Is there any question over here?
So can you please explain it again?
So I'm calculating the torque about the system, about the point actually that O. So if I want to find out the torque, what I am going to do, I'm using that formula, which is that one. This one is my formula. Torque actually that R cross F. So I have the 4 forces over here on the system. I'll calculate the torque for this wheel, including the 4 forces, for these 4 forces on this wheel actually. So if I find out the torque for mg, which is my force, but that force actually acting on that is center of mass, so that's why I give it the R is 0. And for also the n, the angle is basically, because if you write down that formula, R cross F is going to be basically, I need to use that angle. If you use that part, actually the torque, this formula, which would be RF sine theta, but this case the angle is basically that 0 degree or 180 degree. If you say this is actually your R, if you say that is actually the R, if you consider the force acting on that part, but it is towards that direction, right, onto that part, so angle is either 0 or 180 degrees. So that's why the contribution for the normal force, the torque would be 0, and 10 Newton is also acting on the center of mass of that wheel. So that's why that the torque contribution by the 10 Newton force on the wheel will be also the 0. So that's why I write down the 0 over here. And for F, which is acting over here at a distance actually the R from this rotational point, but this one makes an angle actually over here the 90 degree, right? That's why it should be F into R. But I give the minus sign because this one is rotating about that clockwise direction, so that's why torque would be negative over here. We consider the counterclockwise torque is positive and the clockwise torque would be negative, so that's why I give the minus sign over here. Alright, do you understand that part? Fine. So then I can find out this torque would be, I know the F, which is 4, and I know the R, so it should be minus, why it is disturbing? So it should be minus, the force is actually the 4 Newton, 4 into R is basically how much? R is given is 0.3 Newton, sorry, 0.3 meter. So then I'll find out this torque would be, this torque is going to be basically minus 1.2 Newton. This is the torque. Fine. Now if I want to use that formula, which is actually torque actually that I alpha, I'm going to find out that alpha would be also, because we have a relation actually that A actually that alpha R, then the alpha should be A by R, and this alpha would be also the negative because it will be rotate about that clockwise direction, right? If we apply, look at this, if you apply the force onto that wheel in that direction, the wheel must be rotated in that direction, then it will, that acceleration will be towards that direction A. So that's mean this angular acceleration alpha, since it's rotating to the clockwise, alpha would be negative also over here. The clockwise direction is negative we are considering for the case of rotation. Then I'll find out that alpha from here negative, then I should be torque divided by alpha. You can find out this one directly. So torque is minus 1.2 and alpha is minus, acceleration is given which is 0.6, and R is given which is 0.3. Then you can find out this moment of inertia for this wheel I should be basically, if you solve, you will find out it's going to be basically that 0.6 kg meter square. So that should be basically that moment of inertia. You understand this part? Remember, this is the calculation we calculated the moment of inertia for this for this wheel actually about the center of mass, which is that point actually we are calculating. You can also find out, if you want to find out the moment of inertia for this wheel about this point or any other point which is parallel to this axis, you can use the parallel axis theorem to find out the moment of inertia for this wheel using that way. Alright? Alright, let's come to another point actually. One more thing, guys, please give your attendance right now. Just write down your ID. Alright, I think done by everybody. Fine. Yeah, let's talk about one more topic. Let's say this is a flywheel actually. You did that experiment in your lab, I think. Let's say this is a flywheel is connected to a wall actually. There is a mass that's also connected with this flywheel. It can be rotated about this point actually. The mass of the flywheel actually that bigger mass m, and the radius of this flywheel actually that r. The mass of this one actually that m. And this one, this mass at a height h from the ground. Let's say this is the ground, which is actually the h. This height is actually the h. So what happened actually when you release that mass, this fly will be rotated towards that direction, that's mean the clockwise direction, and this mass will fall to the downward direction, right? Simply actually that potential energy of this one will be converted to that kinetic energy of this flywheel, which is rotational kinetic energy, simply because the center of mass of this flywheel is not moving at all. So that's why the potential energy of this mass, small mass, will be converted to the rotational kinetic energy of this flywheel over here. Alright, so this some data is given actually. The mass of this flywheel actually that 2.5 kg, radius of this flywheel is 20 centimeter or 2.2 meter. Mass of this block is actually 1.2 kg, and that height is actually that 1 meter. You release that system actually from that height, and this string actually, that ideal string, is not inextendable and massless string we're using over here. Now they ask you a lot of question over here. First question actually, they ask you calculated A and alpha. You know that which could be correspond to which one. The A should be this block and the alpha should be for this flywheel, right? Because alpha is rotating. This one actually, this one has a rotational motion, this one has a translational motion over here. This is the first question. Second question is calculate the tension in the string. Third one is that find that velocity, simply just find out that rotational kinetic energy of the flywheel when the block hit the ground. So that's mean after traveling 1 meter of the block, what should be the rotational kinetic energy of this flywheel? This is the question, actually, that part. Alright, fine. So to solve this part actually, if I somehow can find out the alpha or A, I can find out the other one, because I know there is a relation between that linear sorry, linear acceleration to the angular acceleration, right? A actually the alpha r. I'll try to find out that A first, then I'll convert that to from A to alpha. Fine. To find out that A, I need to use that two equation over here actually. What I'm going to do, I'll draw the free body diagram of these two objects. One is actually the flywheel, another actually this block. If I draw the free body diagram, I can say there are two forces will be acting on that. What's wrong? It's not responding. Can you see my screen, guys? Hello?
Yes, sir.
Alright, so I'll draw the free body diagram of this system. So one force would be basically your, this would be mg. This should be the tension over here. And for the flywheel, you will find out this would be actually that mg. This will be actually that normal reaction force for this one, and this would be also the tension on this string. Alright, so this is actually the free body diagram on this part. How many minutes do I have? Only 5 minutes, right?
2 minutes.
2 minutes? I think it's 5 minutes.
Okay, sir.
Otherwise I cannot finish that part actually. Otherwise I need some extra time actually. Can you give me 5 minutes extra, then I can finish that part actually over here. Otherwise what I can do actually, I have to actually that recorded this video from other section, then I will upload it that part actually in your section. What do you think? Can you give me 5 minutes extra, or I will record it that part and up to actually that YouTube channel? Which one will be suitable for you?
Sir, I think you should keep continuing, and
Alright, that's good.
we will stay still how much we can.
Yeah, that's fine. That's great. Yeah. Alright, so this is actually the free body diagram, right? So what I'm going to do, I'm going to actually that writing the two formula over here. One is the Newton's second law for rotational motion and also the translational motion. I know that formula actually for rotational part, torque actually we express using that formula. Torque would be basically tau would be disturbing. Right, torque actually that I alpha, this is actually for rotational motion, and for translation motion we'll write down F equal to that ma. These are the two formula, right? I'll use over here. But the problem is, one is actually for rotational part and this angular part. Somehow I have to cope up with that system. I'll find out that case actually over here. Let's do that fast. For that block I can write that Newton's second law, because this is actually the translational motion. Then I'll write down mg minus t should be ma, right? Look at this, because that block will move to the downward, then it will be rotated. Then I can say that mg is basically greater than t. So that's why I write down this one actually, that mg minus t actually that ma. This is the first equation for this part. But the disc is not moving, but it's rotating. So that's mean for the disc I will use that second formula, which is this one. Torque would be basically that I alpha. I'll use that part over here. Alright, so to calculate the torque, I'll calculate the torque on the disc about this point actually. So this is actually my R. Then how many force acting on the flywheel? There are three force actually. One is actually the T, one is actually the mg, another actually the T, which is over here, which is acting on that surface. Then if I write the torque for the about that center or center mass of this flywheel, I'll write down this torque should be about the center of mass, which is I say that the O, that contribution by the mg would be equal to the 0, because it is acting on the center of mass, plus contribution by the n is also the 0. This is also acting on that center of mass. If you look at this picture clearly, you will find out that idea over here. Look at this. This is actually, so this is actually the picture, right? This is that mg which is acting at that point, center of mass. This normal reaction force is also acting over here, because this normal reaction force actually provided by that axis of this flywheel, right? You see that you did that experiment in your lab. There is a axis for this flywheel. About that axis the flywheel is rotated, and that axis is fixed to the wall by the two vertical support actually. That vertical support give that normal force through this axis towards the upward direction. So that's why this normal force is also acting over at the center of mass of this flywheel. And this one T is acting over here at a distance actually that R, but due to that one it will be rotated actually that clockwise direction. So that's why I will say this one will be negative over here. Then I will write down simply minus T into R, and the angle between these two one actually that 90 degrees. Simply if you look at this, the angle between the R and the T is basically the 90 degrees. So that's why I write down that sin 90 actually the 1. And that torque must be I alpha. I should be, this is the flywheel, is look like a disc. I'll write down it should be half of m r squared. That's the moment of inertia of a disc throughout the center of mass. That I'll give you, don't worry about that. So this part, and the alpha is this one, and alpha will be negative over here, right? Because that one, due to that T, this flywheel will be rotated in the direction of the clockwise direction. This is actually the T. Due to that one, it will be rotated this clockwise direction. That's an that one I can say the alpha would be negative over here. Then this would be alpha would be negative over here. Then find out. So I'll find out this minus TR should be minus, I can drop this minus sign, half of m r square, and the alpha I can also write down, it should be a by r, right? It should be a by r, because we know that the relation between that a actually that alpha r, we know that relation. I'm using that part over here. That's fine. So I'm going to neglect this minus sign. This r will be cancelled out over here. This r will also cancel out. Then I'll find out simply this t is going to be, would be half of ma. That should be actually that tension on this string also. We are going to also find out that part. So let's say this is actually equation the 2. I'm going to add this equation 1 and 2, because the equation 1 is actually that mg minus t equal to ma, and the equation 2 actually t equal to half of capital MA. So then I'll add this equation 1 plus 2, that will give you simply, if I write mg minus t actually MA, and the t actually half of bigger M into A, right? Then I can add, if I add this t will be cancelled out, this t will be cancelled out. I'll simply find out mg, it should be, if I factor out the A, it should be m plus m by 2, or simply I can find out that A should be mg divided by m plus m by 2. That should be actually the acceleration. You know the everything. You know the smaller mass, which is 1.2. You know the bigger mass, which is actually the 2.5. If you plug in, you will find out that acceleration of that block, it should be 4.8 meter per second square, and this should be downward. You have to give the direction, meter per second square downward. This is the answer of this A, and the alpha should be, in that case you can write down A by R. That will give you actually that 24 rad per second square, and it should be minus, it's a clockwise, or you can write down the clockwise over here. You can write down the CC also stands for the clockwise in a short form or abbreviation you can write down. Second one, they asked me to calculate the tension, which is I simply write down half of MA. I know the A, I know the M, then I will find out this one is going to be 6 Newton. This is actually the tension in this case. Alright. The answer of that part. Now the third question, they asked me to find out actually the rotational kinetic energy of this flywheel when the block hit the ground. I know that rotational kinetic energy we can find out using that formula half of I omega square. Right. I can find out the I for the center of mass, that is given actually, which is half of mr square. Now I have to find out the omega when the block actually hit the ground. I have to find out that omega over there. Fine, that I can find out using that formula. I know that omega could be find out using that formula V actually that omega R. That means when the block hit the ground at what velocity strike, at the moment what should be that angular velocity of this part. Since this string is inextendable over here, then I can use this formula to find out this angular velocity omega for that part. Fine, that means I have to know that velocity. I know the R, then I will be able to find out this angular velocity using that formula. To find out that velocity V, I have to know at what moment actually, it doesn't care about to find out that one. I can use this one simply. I'm going to find out the velocity of that block when it strikes the ground using that formula actually. V square actually U square plus 2AY, U square plus 2AY, right? What should be the value of A over here? A should be basically that one you calculated over here, not the G, because it's not a free fall. A is actually 4.8, right? U would be 0 because you start from the race actually. So that's why I'll find out the V would be root over A Y. Y actually the H, which is the 1 meter. Then you will find out this V would be basically the 3.10 meter per second. If you know the V, you will be able to find out that omega, because omega should be in that case V over R. R is given, which is 0.2, 3.10 divided by 0.2. You will find out this one would be 15.5 rad per second. This is the angular velocity. Now if I know the angular velocity, then I'll be able to find out actually that rotational kinetic energy, which I am simply write down Kr would be half of I omega square. I can find out the I using that formula, so which is half of mr square and omega square. You know the everything. You know the mass of the flywheel, you know the radius of that flywheel, then you will find out rotational kinetic energy of this system is going to be 6 joule. That's the answer of this question number 3. All right, guys. Thank you very much. Thank you for your extra time. Is there any question over here?